Are you ready for one of the weirdest concepts in all of 3D? I hope you are, because that's what we're about to discuss. You see, here's the trick. When I talk about three-dimensional objects, I'm talking about things that have length and height and depth. Those are your three dimensions, x, y, and z. However, you'll note that as I've been talking about all of these objects, I've been talking about them in terms of vertices and edges and faces. We'll just scribble that in. We don't need to fill that in nicely. Now, the trick with this is that it makes a plane. The face is a plane, and a plane is technically a 2D surface. So when I look at my cube, the cube is not solid. It is completely hollow. It is made of 6 two-dimensional planes. Here's the way that works. The cube appears to be 3D because I am viewing it in world space. So world space is a set of 3D, we'll call them x, y, z, coordinates, in which objects are given the appearance of depth. World space. So when I look at objects in world space, they appear to be three-dimensional, like my cube and like my lightning bug. They appear to be three-dimensional. However, let's just change color real quick. We'll grab this nice orange color. The concept on which individual faces work is a concept called local space. We'll go back and make that orange later. So local space is a set of 2D coordinates, and the two dimensions that we're working with are the u dimension and the v dimension that form an object's surface. So local space is 2D. The two dimensions are u and v. And that forms the surface of an object. So with local space, if I look at the cube in local space, I won't see it as being dimensional. I'll see it as being maybe something more like this kind of a shape. And now you can see I've got the same, not quite the same, basically the same number of planes, but they're all arrayed out in a grid, so instead of looking at them dimensionally, I'm seeing them all one at a time. So those are my local space coordinates for this cube, and back over here in 3D, I pulled up the local space coordinates for my lightning bug. So although it looks dimensional, it is in fact the same thing here, it's just flat. So you can see there are its wings, there are its bodies, all of its little legs, its little antennae. So there's all of its stuff. It's just flat instead of dimensional. So world space is like the world we live in and the air we breathe, and local space is the flattened skin of an object surface. So your 3D objects aren't really dimensional. They're all flat, they just appear to be round because they live in world space. Like I said, that's one of the weirdest concepts in all of 3D. As a last note, one of the things that helps this world space local space relationship really work is one last piece of vocabulary. I'm going to pick a new color. Maybe we'll go for a green, we'll go for a darker green. All faces, from this face that I've drawn over here to all of the faces on the cube, have an imaginary line sticking out of them. It's really hard to draw this one, I'll just draw a dot. That dot is facing you. This line is called a normal. And the normal is an invisible line that indicates which direction a face is facing. So polygonal faces, like the ones I've been drawing, are kind of like playing cards. They've got a front and a back. The normal tells me which way is front. You can't see your normals by default, they are completely invisible, but if I go back into 3D, all of my faces are currently facing the camera. I can take some of them and I can reverse them so they are facing the other way. And you'll see that what happens is I start getting these really nasty lines because now some of my faces are in fact facing away. It's a nifty concept and it helps you keep track of what's front and what's back at any given point. Hopefully they're not something that you'll have to worry about until you get to be a little bit more advanced as a modeler. But it's something for you to keep in the back of your head. All of your polygonal faces are just like playing cards. They have a front and a back, and that's because they are completely flat. They flatten out into UV coordinates. But when we see all of those UV coordinates together in the XYZ world, they form a really beautiful, intricate, three-dimensional model. I hope you enjoyed that. I hope that you learned something. In the next set of videos, I will start talking about the 3D interface we're going to be working with, and from that we will build up and start modeling.